Going live, going live, going live. Always want to wait just a little bit to make sure everything's ready. And we are definitely live. Hello, everyone, and welcome to a historic day. Today is meetup number 70 of the Data on Kubernetes community. Very, very excited to be here with all of you. We've got an action-packed session that really addresses the core message that we're trying to send about how to run stateful workloads successfully on Kubernetes using open source technologies and working with amazing people that are using them, able to show us how those technologies are applied in an end user scenario. Just before we get started, quick reminders. If you're not already subscribed to us on YouTube, come on, it's really super easy. Just click it right now. You can also check us out on Twitter. We've got lots of stuff going on there, LinkedIn, Slack, etc. If you're new to this whole thing on Data on Kubernetes, you just need someone to explain it. We have a great speaker who's going to give us lots of context. But apart from that, we've got some killer community members that would be more than happy to help you. And speaking of community, a big milestone for us this year was in May when we had our first co-located event in KubeCon. That was super fun. We had over 20 speakers. We did the whole thing live, except for one pre-recorded talk. And we're very much looking forward to doing the same thing in October. Amey and I were just talking about this in Los Angeles. We know that there are a lot of things up in the air still about the whole COVID situation. Safety first, let's all be safe. We've been through enough already. No need to take any unnecessary risks, but it's still planned to go ahead. But we're just going to be flexible with the different kinds of formats. We are planning on doing another virtual event on October 12th. And just so that everyone knows, we are looking, we've launched our CFP. So if you or somebody you know is interested in talking about the topics that Amey is going to be talking about today, all right, about working with stateful workloads on Kubernetes, particularly focusing on the end user aspect, right? Very, very important. So we can get that element in there. Please let us know, and we'd be more than happy to hear from you. Take a look at your CFP and hopefully get you a slot in our event. That being said, our speaker doesn't need too much of an introduction because you can find him all over the place on blogs and YouTube videos. His name is Amey. He's coming from YugabyteDB, and we're going to talk about a few different things today, but maybe, Amey, could you just tell us a little bit about yourself, how you got into the data space in general?
Absolutely, Bart. First of all, thanks for the introduction and your LinkedIn message yesterday. That is amazing. I hope you still have it on, though.
No, not to worry.
Yes. So I'll just do a quick introduction, use the slide just for this. First of all, folks, I basically work in Yugabyte. I lead the team of data engineers who basically focus on helping our end customers and end users with their data problems. These are complex transactional data problems. We solve them irrespective of the platforms, Kubernetes, bare metals, VMs, it doesn't matter. And these are some of the household names that you hear about that we work with day to day, right? The way I got into data systems was like, I went to school in UPenn, distributed systems and networking was the core major that I focused on. Right off that, got in New York Stock Exchange, where you won't even believe how much data we have. It's just amazing, right? So basically started working in New York Stock Exchange on some of the core data systems for market regulations. Basically got hang of some of the systems that the ex-Facebook team had built with HBase and Cassandra and others. Then worked at Pivotal for about 5 years, where Pivotal basically led the advent of microservices, and our teams focus on the data microservices aspect of it. So think of it as shopping cart, shopping wish list, anything which is financial transactions, your financial transfers, those kind of use cases we focused on to ensure there is 100% uptime and an SLA to the end users, and how we go about designing those systems with hundreds of microservices working in synchrony. So that's where my background comes from. Super passionate about the overall data space as well. As Bart and I were chatting about, a lot of friends and family here with different folks participating today from the ecosystem. So I'm looking forward to the talk today, especially because the way we have laid it out is it's going to be very interactive discussions. So keep your questions coming in through chat. We have several members of Yugabyte team ready to answer you real time, and they'll park certain questions where I can address them live in front of you as well.
Very, very good. Really quickly as well, too, because you mentioned that great element of use cases. And that's what a lot of folks are thinking about, too. It's like, we're talking about data on Kubernetes. Are these technologies that are going to be generally addressed to one sector or another? The financial sector definitely seems to be a strong one. What would be some other sectors where we tend to see amounts of data or certain kinds of data where these technologies match up quite well?
Right. So Bart, actually, that's a perfect segue into my first slide. I'll just talk about that real quick, right?
Okay.
So as you folks know, right, Kubernetes, obviously it came in 2015, 2016, 2017. It was like, right at the cusp of getting popular. And 2018, 2019, I would say became really popular. But some of the first early set of adopters were those companies who really had that problems to meet scale peak demand for their enterprise users or their consumers, actually. So the three examples I have in this slide, fortunately, unfortunately, they happen to be the topmost retailers in the country, right? But these were the ones who basically solved their challenges of the peak scale workloads like Thanksgiving, Black Friday, Xbox One launch, PS5 launches using Kubernetes, because they basically started rolling out these prefabricated set of environments where they can go scale up, scale down to meet these peak demands. And essentially, retailers were one of the foremost who would started to get onto this new orchestration layer with container technologies, and Kubernetes being the start, right? Now, all of them started with stateless applications first.
Good,
It's
because that's
simple.
another important part is, how did we get to this debate about stateless and stateful? Yeah.
Correct. So most of them started with stateless applications first because, first of all, it's easy for you to deploy Node.js, Spring Boot, Python applications easily in containers, scale them up, scale them down, put a load balancer, and you're good to go. Once stateless applications were like nailed down in terms of the workflow, we started looking at some of the stateful application services, and that's actually a good segue into my next slide as well. That is, we started looking at some of the core enterprises and large Silicon Valley companies starting to scratch the surface a few years ago in the stateful application workloads. So namely, you had Cassandra's, MySQL, Postgres really showing up, being very popular container deployment topologies to address some of these core critical workloads. And as you go through the CNCF survey and also a VMware survey from last year, you'd see that all of the containers have grown tremendously in some of these enterprises. I mean, you actually have notable set of users who run more than 5,000 containers at a time in their environments, right? These are basically production numbers in most cases that way. But when you look at it the other side, that is, how exactly are these people really deploying it? And the question happens to be like, the enterprises definitely like to leverage their core data center investments and on-prem data centers specifically. So they do most of them on-prem rather than going to GKE or EKS or AKS. So everyone feels Kubernetes brings that most value to them in terms of CI/CD and robust automation. But yes, there is a learning curve. But net, it's a perfect investment to have today to make sure you get everything from that standpoint. That is, developer basically gets a full, complete Kubernetes as a service, regardless of where it's deployed. They can go scale up, scale down their microservices and data layer seamlessly as well. And we all embrace CI/CD automation to make sure that is done correctly as well. So Bart, does that help? Or I can go deep dive into some of those things as well.
I think that's good. And I think these things will come up naturally over the course of the presentation. So perfect. All good to go.
Perfect. Thanks, Bart. So folks, as I mentioned, all of us come from a lot of data background that way. Some of you come from application side of things as well. So I wanted to make this talk a little bit more interesting. That is, I'm going to give you whys of why you should run a stateful service on Kubernetes and why you shouldn't run stateful services on Kubernetes. So I'll give you both sides of the coins that way. So it's a good debate, constructive debate to have. But net, we'll basically talk about what kind of problems are out there in the industry that we can solve together and how the space is evolving. And just to talk about that space itself, right? These are some of the vendors or core projects who have really embraced Kubernetes now and make sure they can run de facto in a very, very seamless way. That is, you have Elastic's, Yugabyte, which is us, Postgres single node, MongoDBs, and Cassandra of the world. We can just go to the Helm charts or stateful set deployments, or even Kubernetes operators in some case, and go deploy it on any Kubernetes environments. You essentially get a feel of database as a service through those kind of deployment mechanisms. But this is something that has evolved, I would say, in the last 3 to 4 years. It was a challenging space before that. And here are the reasons why today you should run your database in Kubernetes. So just going to go through few pointers for you folks as a food of thought and then food for thought. And then essentially we can keep the discussion interactive in the sense, whenever you have any questions, put it on the chat and my team members will basically start responding to you real time that way. Now, let's talk about the first and foremost thing. Whenever you have a CTO or a CIO of a company really looking at Kubernetes, one of the most important things that strikes to them is Kubernetes offers you that something VMs or bare metals couldn't achieve for the longest time. That is really amazing resource utilization. That is, you can basically go deploy anything you want in the same Kubernetes environment. Kubernetes takes care of orchestrating them based on your resources and the limits you have put together, or any constraints like pod anti-affinity rules that you have put together. But you essentially get a really nice packaging and a very high density in terms of better resource utilizations that way. So it's a perfect recipe if you want to create your own private database as a service. Let's say, like if you want to roll out your own Postgres as a service, Kubernetes is fantastic because now you can go click off a button, deploy Postgres, and ensure that your end developers don't have to worry about racking, stacking, networking, where's the IP, where's the load balancer. All of that goes away. But there's a caveat, right? You need to watch out for noisy neighbors. That is, when you're running in production systems and you have like several of these databases and data frameworks that are being deployed on your Kubernetes environment, all of these systems happen to be very chatty or resource intensive because they are IO bound or network bound, or in some cases memory bound as well, right? They can add a whole bunch of noisy neighbor issues on your critical workload environments. And that can either hamper the SLA that you have for your end customers, or in some cases actually have a downtime if what single pod takes consumes all of the disk IO bandwidth or the memory from that perspective. So just a caveat here, be a little bit more careful when you're running these in critical production environments. A lot of rule of thumbs you can go with on best practices, namespace isolation, having a dedicated tenant per cluster, and things like that. Now, the second thing that comes to mind when for running Kubernetes and for running databases on Kubernetes is you can easily dynamically scale up and scale down CPU, memory, and disks without having to worry about anything as a human intervention. That is, you can set up these rules. You can create something called as a Kubernetes operator, or CRD, as we like to call it, custom resource definition. You can essentially script out the whole thing as a way human DBA would be operating a database. You can script out the whole thing based on the health checks and metrics. You can track and embrace automation to do CICD, that is, scale up the workload when the peak hits more than 60% CPU, or scale down automatically when it goes beyond 25%. You can also do rolling upgrades without any downtime. Some of those things which were impossible to do in VMs or a bare metal environment are easily possible in Kubernetes. And this is one of those things where Kubernetes has proven itself to be the best orchestration layer in terms of like running your stateful as well as stateless microservices. The third one, and a very important one, actually, this is why Google had basically created the system back in the day too, right? There's no lock-in in terms of the platform or the vendor. Today, CNCF has certified about 70, 75 different odd Kubernetes vendors, I believe. All of them rely and comply with the core CNCF APIs that are given by Kubernetes community. And you are ensured as a developer or an operator that whatever you deploy gets deployed on any of these CNCF certified Kubernetes platforms that way. That is, like you essentially get to embrace your infrastructure as a code in whole honesty, in whole nature of that, right? You don't have to worry about these kind of things. But there are certain special things, like if you go to a cloud provider like Amazon or Azure or Google Cloud, they do certain things extra, like they go one extra mile to make sure that the customers and their consumers are really embraced with whatever the cloud can provide. And this usually comes in form of a load balancer or a volume type, and the self-managed nature of Kubernetes itself that public and private clouds would offer, right? Now, when you try to go and consume some of these services, like, simplest would be elastic load balancers from Amazon, right? And when you try to port that over to a data center environment, you do have to do certain changes to your code now, or like your Kubernetes constructs, because those kind of hooks are not available in your data center environment. So you need to make sure that whatever solution you design, it is able to embrace the platform like Google or Amazon it's giving you, but not have a vendor lock-in that you cannot port over to the other side of Kubernetes that you're thinking about, right? So you need to, like, there are a few other things that we have well documented in Yugabyte, but keep an eye out on volume types, load balancers, and some of these lock-ins, which cloud providers have developed, which will kill your portability equation out of the in Kubernetes that way. The last one actually is automating the day-to operations. And I touched upon this during the pod and the whole packaging of things. But think of it this way. That is, once you have a good handle on the entire life cycle of your database or a data framework, you can go and embrace CI/CD to automate the whole process. That is, you don't have to worry about any of these changes as a human intervention. You have a Prometheus dashboard and a Grafana looking at it. You can have Jenkins pipeline to go automate the entire thing, and you can leverage Kubernetes operators to go and do it directly that way, right? So essentially, you can now manage a fleet of databases just using one single human operator to go and run this at scale. Now, there are certain caveats again. That is, if you're trying to take a traditional database, let's take, for example, IBM DB2 or something which was built in 1980s and 1990s, right? It's super easy for anyone today to take any software, containerize it, and run it on Kubernetes. It requires no technical knowledge other than the fact that you know some basics of Kubernetes. But is that the way to do it? And if you take certain traditional RDBMS, just containerize it, put it on Kubernetes, you are opening yourselves to those kind of caveats in the sense that is, you cannot really guarantee rolling upgrades without any downtime because it wasn't the way the traditional RDBMS was developed back in the day. So you do have a potential for a downtime or in certain cases, data loss. And we'll touch upon this in the next few slides, if and how you can actually get into a data loss kind of a scenario with this traditional RDBMS. So point to be noted is that you want to ensure you put some kind of a solution in your Kubernetes so that it embraces the full automation that Kubernetes provides. But at the same time, the database exactly knows that Kubernetes is distributed and it is not trying to do something like a data replication or a data backup, which traditional RDBMS were not meant to be. So one of the core mitigations for this is let go your single node databases, try to use a distributed database. It goes a long way to provide you resilience, fault tolerance built into the product itself. Now let's flip the coin. Let's look at what exactly are the things that will basically that we put together on why you should not run a database on Kubernetes, right? That is, first thing is failures. I mean, this is a given truth. All of us embrace Kubernetes, but your pods fail a lot. I mean, they can fail just by container pull image issues. They can fail because your memory is overconsumed or CPU is not available. Resschedulings have issues. So your pods can fail a lot. Your process inside that pod can fail because of OM killer issues or out of memory issues that we typically see in databases that way. And sometimes it's just the config files. I mean, the config files for your traditional databases are so clunky that it takes you forever to go parameterize it. And then one or two issues here and there, your entire database fails because of that single pod failure that way. So what do you really do to ensure that the pod failure doesn't disrupt your database service? Again, as simple as that, you just have a clustered database or a distributed database so that even if there's a failure of one pod or one entire AZ or one entire region, you're still insured, you're still covered, and you can meet the SLA for your end consumers, even if you lose one entire fault domain that way, or two fault domain if you have a higher replication factor. It depends on what kind of distributed database you use, right? So that's very important. One other thing I wanted to touch upon here is that if you use any stateful service, which basically embraces local storage option from Kubernetes, then as and when that pod gets rescheduled to another set of nodes, your local storage will not be available to that pod. So you need to bootstrap that node again with the right set of data, either through external systems or building some kind of a formula so that the bootstrap process is automated that way. So it's a manual overhead that you need to take care of if you're thinking about a single node database running and consuming local storage that way. That leads to our next point. That is, if you use local storage, actually, there are pros for local storage as well today. That is, in last 5 years, NVMe has gotten so cheap that if you want to run a very high throughput, low latency workloads, you should completely think about local storage as an option for your Kubernetes environment. And we are talking millions and millions of transactions per second. something that we routinely do in Yugabyte with our set of customers, right? That is, we have IoT style customers, vehicle telemetry, we have global retailers who easily do million ops a second with Yugabyte. And we do this in form of fashion of using really strong SSD-backed EBS style storage or local storage in some cases as well. So it's always good to figure out what kind of data requirements you have, and based on that, go for the storage options. But one caveat for local storage is that, as I mentioned, if your pod gets rescheduled from one node, one worker node to the third worker node, your disk or the local storage volume is not going to be available. So it's going to see an empty volume, and you need to figure out how exactly you can bootstrap your data here to the third new volume that way. Now, is it possible? Yes, you can absolutely do that. Is it going to be time consuming? Absolutely, yes. If you have terabytes and terabytes of data, it's going to take you network speed and whatever time your database takes to make sure that the new copy of data is available. So you might incur downtime or degraded performance in such cases. On the flip side, you have persistent storage, something that Amazon nailed it in 2005 with launching of EBS. So essentially, API-driven way of getting you elastic block storage. And obviously, everyone else in the industry has now embraced the same model. So you have API-driven network storage. You can get it in SSDs, HDDs, however the way you want it. And you can actually have provisioned IOPS for that as well. That is dedicated set of IOPS as an SLA that you can sign up for getting as close to a local storage volume in terms of performance. That is something it's possible, but it's expensive, right? Now, in terms of persistent storage, it's easy to get that on cloud providers. Like as Amazon started it, Google has it, Azure has it, all of the private cloud vendors also have it. But if you work on on-prem solution, and this is where Bart was talking to us about the use cases, right? If you're a healthcare company or you are in the edge oil and gas kind of data center locations where embracing public cloud APIs is not possible, and you have to deploy your solution on-prem, you want to ensure that the persistent storage is API driven, just like it is in EBS or Google Persistent Volume. Because if not, you're looking at buying certain additional softwares to ensure that kind of experience for your on-prem data centers. So yes, it's possible. You can use external software which takes care of replication and provides you EBS-like solution, but that's an added complexity that doesn't come from your native Kubernetes that way. So again, one of those things is that you can mitigate all of these kind of issues if you just use a distributed database in general. That is, whenever you lose one node, one pod, you lose the entire worker node as well. That's perfectly fine. A distributed database of any kind will know how to tackle those failures and essentially go and mitigate some of these core issues that you see in real life. The third thing, and something that we really struggle with when we work with our set of customers, especially financial services. I don't know why that's the case, but then when you look up to Kubernetes, you want to ensure that you are guaranteeing a tenancy for those kind of end customers. That is, if you are in the financial services industry, you want to make sure that your data for a single tenant is stored physically and logically separate from other tenants that you have, right? So best place to start here would be you can do namespace isolation, at least for their departments, or you can dedicate a separate cluster per tenant. Expensive option, but something you might have to do if at all your tenant really requires that kind of guarantee that you're making sure the data and compute is separate. So in those kind of cases, whenever you're trying to expose the service from one Kubernetes cluster to another, so let's say you have a whole bunch of microservices running on a shared cluster, but the data resides on every separate Kubernetes cluster with a dedicated database on top of it, the only way your microservices can access that external service will be using load balancers. Now, on cloud providers, they have nailed it, like Elastic Load Balancers and others. You can get it API-driven, on the fly, internal or external load balancers without any issues. If you want public IP address, yes, it may cost you a little bit extra, but that's fine. At least it's available. But on-prem environments, you have traditional load balancer companies who do most of the global load balancing. for some of the services that we use today. And some of these may not be completely API driven. So F5 is a perfect example, really solid load balancer. But how do you integrate F5 in your Kubernetes environment to make sure that you get the same experience that Amazon Elastic Load Balancer provides you? And this is something that we day to day look up to other alternate solutions, node port being one of them, but it's very, very bad in terms of security risk that it exposes to the end customers or the network services as well. So something to think about, that is, if you're really trying to build your own stateful service on top of Kubernetes, load balancer is going to be one of those key critical things that you need to solve for. Once you solve load balancer, that's where the other set of issues comes together. And this is where we have a tiger team in Yugabyte to solve some of these core problems for our Fortune 500 enterprises. That is, a lot of these customers now want to run a distributed SQL database like Yugabyte on top of disparate or separate Kubernetes environments. Now, by definition, a Kubernetes environment and its kubedns only understands the DNS namespace inside its cluster. That is, there is no way for you to have a Kubernetes cluster talk to other Kubernetes cluster without going through some kind of networking techniques. And these happen to be really complex networking techniques. But fact of the matter is that when you're trying to build a distributed database service, you want to make sure your pods from one cluster of Kubernetes can go and resolve the DNS names and IP address of the other cluster as well. That's like table stakes for any distributed system to work together. And they should be able to talk through TCP and other things, right? So these are some of the things that we started solving for, I would say, a couple of years ago. One of the core technique that we use in Yugabyte is called DNS chaining. It just means that you take different Kubernetes environments and you hook up their kubedns system so that each of the kubedns per cluster has a know-how of the other clusters, pod names and DNS entries and things like that, so that the network resolution and pod-to-pod connectivity becomes easy. So that's one of those things that we do. But it's operationally complex when you're trying to do it on on-prem environment, where you'd have to poke so many firewall rules and make sure that get enough permissions from the infosec on what you're trying to build. The other option, which is something that we're just trying to embrace it, but we have proven that it works, is leveraging certain service mesh style options, like Istio being one of them. That is, you have separate Kubernetes clusters, so you can now build a multi-cluster data layer using Istio, so that Istio will take care of discovery, your traffic, and communication across these different systems. But it's going to have lower performance compared to the core TCP routing that you get from the native layer 4 networking concepts, because you're going to be encapsulating all of this into HTTP layer. But if this is of something interest to you, we did a talk at KubeCon just a few months ago on how to build a multi-cluster data layer using Yugabyte and separate Kubernetes clusters. Again, this is something we would think of this as a future that's coming into the industry. But today, it does have lower performance than if you're going with a native route, like using DNS chaining in that case. Now, putting all of these things together, and this is where we started looking at Yugabyte on how we can go and build a product or a project, actually, of embracing some of these core techniques that Kubernetes gives us, but at the same time, alleviating the problems that single node databases or even legacy vendors were facing. So when you run Yugabyte as a distributed SQL database on top of Kubernetes, you essentially get all of those things that I mentioned about in the green. You don't have to worry about pod failures or local versus persistent store. Yugabyte takes care of replication and resharding your data automatically. But yes, there are certain open topics like load balancers and network complexity, and also operational maturity curve. But this is something based on the reports that we see in 2021. We have gotten past this. I mean, everyone's pretty familiar with using Kubernetes and keeping track of the new things that Kubernetes is building us for. And that is a perfect segue into what exactly is YugabyteDB. So I'll take a quick pause here. Bart, if there are any questions, I'm not seeing them on the Zoom chat, but any questions, please let me know. I'm happy to answer that right now.
In YouTube. So we've got, let's start at the bottom actually. Is DNS chaining implemented on principles of blockchain where one block has info about the other blocks?
No, it's not. DNS chaining is a simple networking concept You take multiple DNS servers and you basically do a discovery between the other servers. It has nothing to do with blockchains. I hope it had, but today it has nothing to do with blockchains.
Okay. Then the other two questions are kind of related. So if we're using distributed databases, what kind of use cases match up with non-distributed databases?
Right. So actually, I'll cover that later in some of the slides today. But
okay.
Think of it as there are a variety of use cases where distributed SQL databases are perfect. If you want fault tolerance, resilience, and HA built into your service. But if you're trying to do a package solution like a POS checkout, and you want local database, you don't have to worry about talking to anyone through network. A single node database is a perfect solution for you. You don't have to worry about distributed nature of things at all in those kind of cases.
Very, very good.
But I'll touch upon that later.
Yeah, keep going.
Perfect. Cool. So as I was mentioning, we started building Yugabyte in 2015 with a core goal of bringing a transactional distributed database to the industry, and which can basically solve those three things that I mentioned. That is resilience, scalability, and fault tolerance built into the product. That is, you don't have to worry about your classic Oracle and Golden Gate kind of combinations. Now you can rely on a database which will take care of rebalancing, resharding, scaling the data at peaks without having to do anything from a human intervention standpoint. And obviously, these are transactional systems, right? So we are 100% asset compliant, Jepson tested system. Now, in 2015, 2016, if you want to start a new database company, it would have been impossible to create a company without having 100% open source backing nature to it. So that's why we decided to 100% open source Yugabyte with the Apache V2 license. We did some market analysis and figured that Postgres was the most popular SQL dialect out there. So we ensured that we are 100% Postgres compatible from that standpoint. And we really embrace cloud native solutions that way. That is, we designed this database so that you can run it on any environment. That is Kubernetes, bare metals, or virtual machines. We don't differentiate across any of them. You get the same exact experience when you're launching your own Yugabyte database as a service, either in your on-prem environments, your cloud environments, or if you want, you can just consume Yugabyte Cloud, which is purely managed Yugabyte service from our SRE teams as well. So you have multiple options to go through with that. But let's look at why did we build this? I mean, there has to be a core reason and a driving factor to building something in life, right? It's a very heavy investment in building a brand new database in this day and age. So that's where our heritage comes from. That is, the founding team of Yugabyte essentially led the core data transformation inside Facebook. That is, back in 2007, Facebook, as most of you folks know, had about tens odd million users on back of a sharded MySQL architecture that Facebook had custom built. Now, the problem was Facebook had massive goals of achieving more than 1 billion users on the planet within next 3 years or so. And MySQL sharded architecture wouldn't be able to keep up with it. So that's where the core founding team in Yugabyte put their heads together and created Cassandra initially to go solve for this kind of use cases. And then they moved on to Edge-based so that they can essentially manage the entire backend of Facebook Messenger and some other parts of Facebook infrastructure that exists today was entirely on backs of the things that the founding team in Facebook basically dealt with until 2012. After which, they basically started thinking about what should be the next big thing that should we work on now that we have created NoSQL movement in the industry. And that's where our heritage goes back to a lot of us come from Oracle. So that is, we have built some of the core systems inside Oracle, which are transactional, whether it's storage layer or the query layer. A lot of Yugabyte team actually has built core backend of Oracle Oracle PLSQL also that way. So we wanted to take all of those things, and with our experience of running Facebook's core data infrastructure, putting this together and creating Yugabyte, which should basically go and solve for some of these transactional problems and use cases that we see in the industry. Now, we are not the only one who thought about this in 2015, 2016 timeframe, right? So if you look at some of those charts from DB engines, yes, Postgres adoption has been skyrocketing in last decade or so. But more than that, we had Amazon who was trying to build Amazon Aurora, and they were very successful with Amazon Aurora offering. That is a perfect distributed SQL which can essentially give you all the RDBMS features and provides you Postgres as well as MySQL API, depending on what kind of use cases you want to go after. The only caveat is that they have a shared storage architecture, so they can only perform all of these things in a single region and then do eventual latency, eventual consistency to the separate region. And more importantly, they have one single master taking all the writes. So that way you are bottlenecked by whatever scale at which you can run that single master node with. On the flip side, you have Google Spanner, which today powers almost entire of Google Ads and Gmail and Google Maps. And if you look at Google's revenue sheet from last week's, all of that comes from the ad business, right? Most of Google revenue comes from these kind of ad-based systems, and it's completely backed by Google Spanner today. So when Google launched Google Cloud Spanner back in 2018, they essentially made sure that it is targeted toward those high throughput, low latency use cases, but they did not choose a specific dialect of SQL. So essentially, you kind of get into vendor lock-in if you try to craft your application to Google Spanner, because then it doesn't use Postgres dialect or MySQL dialect. And it's hard for you to pull it back or put it into a different platform of a database that way. So some things that you need to be aware of if you're trying to use Google Spanner or Amazon Aurora that way. So what we did was, we basically started looking at learnings from some of these core companies that were getting built. And we created Yugabyte as two different layers of the database. That is, lower half of the database that we call a distributed document store is essentially inspired by Google Spanner. That is, just like Google Spanner, we have a very high density store, but we go and leverage one of the core projects inside Facebook called RocksDB. That was a clone of LevelDB. And we customized it to become a key to a document store. And using Raft as a consensus algorithm from Stanford, this layer is essentially guaranteeing you ACID transactional guarantees. That is, it's 100% scalable, gives you strong consistency on backs of Raft, and also takes care of sharding and rebalancing the data automatically. But on top of that, we looked at the market and we basically have a pluggable query layer. So we have Postgres as one of the entry points, PostgreSQL API as one of the entry points inside Yugabyte. And the other API is Cassandra API, because we have our heritage building Cassandra inside Facebook. So we made sure that there are two entry points into the database so that we are able to solve for most of the transactional use cases that are available in the market. So essentially, every node of Yugabyte looks like this, and you can basically go and achieve a highly available, horizontally scalable solution right off the bat. One quick thing I wanted to highlight here is that you will see a lot of disparate SQL databases who take different routes, like Aurora or Spanner, but it's hard to really achieve the 100% Postgres compatibility if you don't reuse what community has built for you. So that is, what we have done is the upper half of the Postgres that Yugabyte has, we basically took 11.2 version of Postgres and made it work on a distributed storage engine that Yugabyte had built. So that's why we are 100% compatible with anything that 11.2 version of Postgres gives you. And we are in the process of migrating to 12 and eventually version 13 of Postgres that way. But if you don't embrace the community and you're trying to rewrite your query layer from scratch, it's very hard for you to support some of these server-side functions. And something that community has built for last 2 or 3 decades in Postgres, we just get to embrace that and contribute back, versus some of the other vendors try to rewrite Postgres layer into their own language choices. And it takes a long time to go and get adoption that way. Now, with that being said, and this is again, Bart, goes back to your question, that is, what are the use cases for a distributed SQL database like Yugabyte, right? Now, first and foremost, let's think about how do we exactly deploy Yugabyte? I mean, it's a distributed database. So at minimum, you need 3 fault domains for Yugabyte to work properly. That is, yes, you can run it in single node in your laptop for dev test kind of environments, but in production, you still need 3 different RF3 being the core tenant there. You need 3 different fault domains for Yugabyte to run correctly. And they are essentially offered in one of these 3 flavors by your enterprise customers. That is, you can have a single region, let's say Amazon US East, and you can have AZ1, AZ2, AZ3, which are 3 separate fault domains. And you can now run a single Yugabyte cluster on top of this, which is strongly consistent and is able to take care of all of these database transactional issues, because it is on the backs of the architecture that I just mentioned in Yugabyte. That is, we take care of rebalancing and resharding the data. In an event, the entire AZ goes down. In this case, you have no performance degradation or no downtime to your end applications, even if you lose one entire fault domain completely. Now, as you go from left to right, the only variable that changes is the latency. That is, in a single region, you're typically looking at 2 to 3 millisecond latency. In a single cloud multi-region, you're looking at close to like 25 to 50 milliseconds, depending on the flavor of cloud that you have. In a multi-cloud multi-region, you're definitely looking at northwards of 50 to 80 milliseconds that way, right? But nonetheless, Yugabyte still provides you strong consistency wherever you go and deploy such a solution. That is, even if you deploy on, let's say, AWS, Google Cloud, and Azure, a single Yugabyte cluster will provide you strong consistency and data correctness, something that no other database vendor provides you today. So that's the cool thing that we started working on. Again, not all customers embrace 3 clouds that way, but most of them embrace 2 on-prem, 1 public cloud, or you will have 2 public cloud, 1 on-prem, or you can deploy it on-prem in 3 different availability zones. We support all of these models in terms of deployment topologies. Now, that being said, it's a perfect deployment topology. But how does it really work on Kubernetes? It's always a question, right? Like, what kind of things we chose to run it on Kubernetes? Did we choose stateful sets or daemon sets or things like that, right? So what we have done is we basically, underneath the hood, have 2 separate processes inside Yugabyte. That is, there's something called as a master service, which just takes care of state coordination. That is, it's itself its own Raft group, which takes care of like, what does a membership look like in my cluster? How many, is there a scale up, scale down event and things like that? And it just takes care of tracking that state. So very lightweight process that basically runs in its own separate stateful set. And typically you deploy RF3. So that would basically be limited to 3 separate pods running inside a stateful set. But then, and obviously masters do not keep any data, like all of your data reads and writes directly go to something called as tablet servers, a term we borrowed from our edge-based heritage. But think of that tablet servers as essentially your stateful set, where you can start small, like three pods, and can scale infinitely. And when I say infinitely, I think we have tried about 350, 400 pods, and it works perfectly fine. Back in Facebook, people used to run like about thousands of nodes of HBase, and given our heritage there, we can easily go and scale up that. But nonetheless, we have benchmarked Yugabyte on very high numbers that way, and something that is available on our blogs if you folks are interested about. But this is how the 2 stateful sets in Yugabyte basically form crux of the architecture in terms of deploying on top of Kubernetes. Now, to ease the process, we package them in something called as Helm charts. So you can essentially go to this website like charts.yugabyte.com, download our charts, and once you go and deploy the simplest Helm chart with three pods that way, 3 pods per stateful set, you essentially get this kind of a cluster. That is, let's assume you have 3 worker nodes. Each of that worker node is going to have 1 master of Yugabyte and 1 pod of Yugabyte. Internally, we'll take care of having a global transaction manager and using Raft as a consensus algorithm to ensure data correctness and replication of data automatically. You don't have to worry about it from Kubernetes standpoint. We take care of that. Now, that being said, since we are pretty popular in the Kubernetes community and a lot of our enterprise customers consume Yugabyte from that lens, we ensure that we are certified and we validate against a whole bunch of Kubernetes vendors out there. Now, all of them comply with CNCF's API standards, so we don't have to worry about anything. But some of them have special techniques to do load balancers, volume types, and we ensure that our nightly CI/CD build, and before releasing any new version of the product, we go through entire set of testing for some of these platforms that you see here. So namely like OpenShift, which is very secure way of deploying Kubernetes, has different APIs for security. So we made sure we worked with the OpenShift team in collaboration to create a Kubernetes operator, which is specific to OpenShift deployments. But for rest all, a simple Helm chart or a Kubernetes operator from Yugabyte is sufficient to make sure that you get the entire database as a service experience on top of your Kubernetes. So Bart, I'll pause here a quick second because I have a quick demo. But any questions so far?
Here. So one of the questions is, how does Yugabyte handle large batch transactions?
Yeah. So we do have, so as I mentioned, Yugabyte has two APIs. We give you option to batch your transactions correctly on the client side API itself. And once the batch appears, it appears as a single RPC for us so that underneath DocDB, it's SS tables. So similar to Cassandra concept, we use SS tables with RocksDB here, and we are able to handle batches very easily. And that's one of the primary reason why we are really popular in IoT, vehicle telemetry, those kind of use cases, where you have customers writing whole bunch of batches, which translate into easily 1.5 to million or 2 million ops per second. We're able to do that without any back pressure in terms of compactions or latency or any of those things. And we have robust documentation for this topic on our official documentation as well.
Okay, cool. Next question. We've had quite a few talks actually in our community about Postgres on Kubernetes. Are there any things that you could think about, that some of the issues that people might face if they only use Postgres as opposed to using Yugabyte? What are these extras that Postgres doesn't have yet that Yugabyte's offering?
Correct. So I mean, it's perfect to embrace Postgres if you're trying to deploy microservices sitting next to your Postgres application, Postgres database, and you don't have to worry about like essentially no downtime while doing rolling upgrades and things like that. Because when you look at Postgres, you're going to have downtime when you're doing a version upgrade or a scale out or scale up or scale down of that pod. Or essentially, whenever you want a HA kind of a service, you need to do application level sharding to ensure that different set of Postgres have different data and schemas in there, but your application will have that context. If you're okay with those kind of things that most of the enterprises do, it's perfectly fine. But if you want database to take care of those hard things, and you just want a simple stateless application connected to the database, and you can scale up that application to 100 different instances, then that is the entry point for you to think about distributed SQL database, and Yugabyte being one of those good ones who support Postgres completely.
All right. And the last thing, just really quickly for clarification on technical terms. Someone asked, I see the term MVCC and ref consensus replication in DocDB, distributed document. Can you just explain what those two things mean?
Correct. So essentially, as I mentioned, Raft is a consensus algorithm that we picked from Stanford. That is, it's actually our way to implement as close to Google Spanner as you can get in the open source community. Now, Google Spanner uses Paxos. Paxos is amazing, but it's very hard to go run it at scale and build it. And it has certain things that only Google's army of engineers can manage because it's a managed service. Since we wanted to embrace open source and anyone can run Yugabyte natively, we went to Stanford, used Raft. We customized it heavily so that it can scale up, scale down without any issues. So that's what Raft gives us. That is essentially Raft groups are something that provide you strong consistency and data correctness inside Yugabyte. And each of these nodes, each of the tables you create are sharded automatically in something called a tablet. And each of the shard and its two other replicas in RF3 deployment will form a shard, will form a Raft group. So that's the core nature of it. Now, when it comes to MVCC, every single node in Yugabyte runs this distributed transaction manager. And we ensure that we are able to provide you really good transactional support in terms of like the isolation level, as well as whatever you can get from your legacy databases. We do our best to make sure we are able to support that. That is, currently, as we speak, we are also looking at read committed levels in terms of isolation and making sure that your legacy Postgres or Oracle workloads can easily migrate to Yugabyte, even if you are using the lowest level possible in terms of the isolation level as well. And that's where distributed transaction manager and MVCC comes into the picture in Yugabyte. Again, it's a deep topic. My CTO has done a fantastic 90-minute talk just on this topic. I'm going to send it to you right after this.
Perfect. All right, let's jump into the demo.
Perfect. Bart, how are we doing on time? 10 minutes, right? Okay.
10 minutes, yeah.
Perfect.
Don't worry, if we go a little bit over, that's okay. You may have to do a hard stop. We've got time, so don't worry about that.
Cool, thanks. So folks, for this demo, we picked up the hardest problem that you can actually do with Yugabyte on Kubernetes. That is, we started doing demos, which local node, local laptop, single node kind of deployments of Yugabyte, but all of you can do it just by going to a documentation or charts.yugabyte.com. So what we have for demo for you, this is something that one of my teammate, Alan, and I worked on for some of our largest customers. And essentially getting you essentially think of it as a single Kubernetes cluster, which is deployed across three separate Google Cloud GKE environments. That is, these clusters had no clue of each other. So we did the DNS chaining, as we talked about before, and we are able to get a single Yugabyte cluster, which can now withstand a failure of any of the entire region of Google and still be able to serve you 100% uptime without any performance degradation. So that's what we wanted to prove it out, that how you can do it. And for this kind of a demo, we basically put out a little bit of a smaller footprint that what most customers would use in production. But we took 3 GKE clusters. Each one has 3 nodes in it, simple N18 standard ones, and 4 cores per pod is what we went with. Now, to get to the demo, I just wanted to touch upon one of the core concepts and one of the core philosophies we have in Yugabyte. That is, we embrace CI/CD and automation completely. I mean, we are the authors and creators of database reliability engineering techniques back in the day when the teams worked in Facebook, because they were able to manage hundreds of petabytes of data at scale in Facebook with minimal human intervention. And to do that, we essentially created a product inside Yugabyte called Yugabyte Platform. So essentially, think of Yugabyte Platform as a simple containerized application that you deploy in your Kubernetes or VMs or bare metals, it doesn't matter. And it allows you to run Yugabyte as a service on top of any Kubernetes or cloud providers natively. So think of it as one single entry point, which should basically go and allow you to do Yugabyte as a service for whatever department you need. We fully embrace CNCF. So this is a definition from cloud native in terms of CNCF. That is, we ensure that it's resilient, manageable, and observable. And you shouldn't take my word for it. So you should see that in action, how we do it. That is, this is a containerized web application that I mentioned, Yugabyte Platform. For the first time when I log in as a super admin that I logged in as, I get to go and choose what kind of clouds I have access to in my enterprise. So let's say I have Amazon, Google Cloud, Azure. I can just go create IAM roles, upload the JSON in case of Google Cloud, or upload it a secret or an IAM role on the instance in terms of AWS. And I just hook up these credentials. These are stored in a secure way inside Yugabyte Platform. For today's demo, we basically went and created 3 separate GKE clusters, and we basically have their kube configs listed here, so that whenever you try to create a config, the way we access your Kubernetes cluster is through kube config and a simple service account, which is limited to Yugabyte. We don't need root admin or admin access at any point in Yugabyte that way. Once you do that, and also if you have the on-prem VMs which are lying around, you can do the same. That is, get a CIDR block for those VMs, hook them up in our catalog, and from there you go. You can essentially go and create your own Kubernetes, your own Yugabyte as a service on top of your Kubernetes that way. So for this demo, what we have done is we essentially created that simple Yugabyte cluster, that is a distributed Yugabyte cluster on top of 3 separate GKE clusters that you see. It runs a simple 9-pod cluster, a workload that is running right now, and you're able to go deploy this at scale or scale up or scale down just from this menu itself. So think of this as I'm doing 1,000 ops a second, and let's assume for some reason my CPU was hitting 80%. I can just quickly go edit and scale up my cluster to 30 nodes. It's going to basically go spin up these extra 21 pods on behalf of Yugabyte in your GKE clusters, and get and make sure that they are attached to the current cluster, like current Yugabyte universe, take care of resharding and rebalancing the data without any downtime to your end application. This is on the backs of the Helm chart and the stateful set and the Yugabyte operator that I had mentioned before. We just wanted to provide a clean, seamless UI to do it. So that's one of those things. Second thing, in terms of the CNCF definition of cloud native, we ensured that you're able to track every single metrics that's absolutely possible from a database standpoint. That is, we routinely stream these metrics starting from high-level API or as low as how your disks are performing. And do you see any bottlenecks or thresholds on your disk that you should be aware of, and quickly generate an alert on making sure that if there are any usual suspects that we should go after, that is rolling over the logs, we automatically take care of it. But if there is one of the disks that is getting full or accidentally deleted, you can take a quick alert. You can have a PagerDuty integration with it, and make sure that your system is fully observable and manageable from that standpoint. Now, apart from that, all your day-to automation that you can think of in Kubernetes, we've just automated a whole bunch of that. That is, we can do regular scheduled backups in Yugabyte. Just click of a button, you choose any of the blob store that you have, object store that you have. So let's say Amazon S3 or Google Cloud or Azure Container Storage, and you can just take care of backup of data without any issues. It's a distributed transactional backup. We also support point-in-time recovery if you want. If you accidentally delete a table and it happened to be after your last backup, no issues. You can go back in time, just like the Apple Time Machine feature, and go back, restore the state of the database to that point in time, and get back your data that way. So these are some of the core fundamental things that we have built in Yugabyte, and using Yugabyte platform, we are able to give you seamless access to that as well. Now, in terms of how the pods are laid out, this is a simple topology. That is, each cluster, basically, each cluster of GKE there runs 3 tablet server pods and 1 master pod. And this in totality would create the entire Yugabyte cluster. So you're essentially looking at 12 pods, that is 3 masters and 90 servers in this case. Now, you can just go and try out Yugabyte platform through charts.yugabyte.com. As I mentioned, just go ahead, grab this, and look at our core documentation to go if you need any more help from that standpoint. Now, it's good to do this kind of a demo because I want to now focus on how exactly we went across doing this, right? Essentially, having 3 GKE clusters talk to each other is a challenge, but we have automated that by using some of the scripts that are available in our documentation. But the core tenet to that is that we ensured each pod in every single GKE cluster is able to talk to the other set of pods that way. So since you saw we had 12 pods there, each of the 12 pods are able to talk to each other and resolve their DNS names and do RPC calls across each other. That is on the backs of DNS chaining that we have documented here. The second thing is using kubedns and doing the chaining, we are able to do DNS resolution across all of them. So that is, we are able to do TCP-based traffic, communication traffic across all these pods without having to worry about any overhead from HTTP layer that way. The third thing is, and a very important thing that Google actually gives you, is ability to create load balancers. That is, if you look at our current Helm chart deployment, we have 1 load balancer for tablet servers in each of the GKE regions. That is, we have 3 load balancers. So whenever you try to connect to your clusters, you can do essentially a tuple of 3 different load balancers that will automatically route your traffic to your wherever your data resides on those pods that way. The third kind of important thing is you need certain access to make sure you're able to run Yugabyte as a service on GKE. So we ask for a cluster role and a cluster role binding in terms of RBAC policies that way. So something that you can go try it on your own just by going to charts.yugabyte or docs.yugabyte.com that way. Now, that being said, there are a few critical decisions that we had to take to get you that experience. And I'm just going to touch upon these 4 of these on a high level. That is, to ensure very high performance, since we are a transactional system, and as I mentioned, our customers routinely do 500,000 or 1 million ops a second on Yugabyte, we give you 2 options. You can either go with local storage if you have really good NVMEs sitting out there, and if at all you lose that 1 node or pod in Yugabyte, that's perfectly fine. You can resurrect the pod in whatever new node is available, and Yugabyte takes care of re-bootstrapping that pod with the available set of data from the other pods that way. So something that you don't have to worry about. But yes, there is a network cost attached to it in terms of like when you bootstrap that new node, all the data movement causes you a lot of network spikes. The other way that most of our members use is essentially using persistent storage. That is going and making sure that you use EBS-like storage that basically gives you really high throughput without having to worry about any of these provisioning. I mean, it basically gives you dynamic provisioning in that case. Other thing is we ensured high performance, but without this noisy neighbor problem, and also not getting into your latency issues. So that way we are able to do pod anti-affinity rules inside Yugabyte. That is, no cluster of Yugabyte will have 2 nodes or 2 pods from the same cluster co-located on a single worker node. That is something that we took care of so that if at all you lose entire worker node, you don't have to worry about its downtime and things like that. And as I mentioned, if you're doing multi-region, multi-AZ, then the networking between each of those things is a prereq, but we have eased out that process for you. Third thing is all of the day-to operations that you saw from Yugabyte platform, that is handling failures, rolling upgrades, backup restore. We leverage Yugabyte's operators and Yugabyte platform to go and do it in the correct way. And this is just on the backs of the entire database reliability engineering techniques that we believe in Yugabyte that way. So you can set your rules in a way that if your CPU hits 80% threshold, you can go use Yugabyte operator to scale up or scale down and decide what you want to do. We give you flexibility to do all of that. The last thing is, and this is a question I get from most of the Kubernetes users, so I'm hoping someone has posted there. That is, even though we run on any of the infrastructure, that is bare metal, Kubernetes, and virtual machines, there are certain things that each of those platform provides you unique to the other ones, right? So we often get compared on how do we, or we often get asked this question, what would it take to run Yugabyte's same workload on VMs versus Kubernetes, given all the advantages and the disadvantages that each of them have? How close to performance parity are you? And in that case, we are literally single digit close to performance parity between VMs and Kubernetes. This is our last benchmark that we had done, running a simple TPCC workload and making sure that you are able to run a same workload in Amazon, let's say on VMs, C5 4XLs, or same one on GKE using similar size pods. You run the entire TPCC workload and you get really good performance parity between those. Now, this is something on the backs of the core distributed architecture of Yugabyte. That is how we do very high density storage, how the reads and writes go seamlessly without any overhead. Those are the things which contribute to some of these performance factors that way. So we'll encourage all of you folks to go take a look at some of these benchmarks yourselves. We leverage 3 or 4 different other benchmark tools to go that you can just run it by yourselves that way. And our TPCC is containerized, so you can go and leverage that and run it as a simple pod on your Kubernetes clusters as well. The last thing I wanted to leave with you is that when you want to consider a distributed SQL database like Yugabyte, you need to really have those kind of use cases where a distributed SQL system is worthwhile in terms of the performance and SLA that you promise to your end customers. That is, if you have a business critical use case like financial transactions or healthcare data, insurance provider kind of thing, or even your simple transactional checkout kind of things, you want to ensure that your system is 100% up and you don't have to sacrifice the SLA because of a failure of a single Postgres pod and things like that. That's a perfect spot for Yugabyte. Like, that's what we strive for. That's what we solve for in the industry. That is, a lot of our customers use Yugabyte because they are using it as a system of record, replacing legacy databases like IBM DB2 or Oracle for that matter. The other thing is, based on our current Cassandra heritage that we have, we are able to highlight and grab a whole bunch of IoT and event style data natively. Like, you can do batching, you can use Kafka sync connectors, sync or source connectors, you can use Spark directly with Yugabyte, and it will understand the topology and cluster awareness and give you really seamless performance with that. This is what we handle massive scale with using our Cassandra, the NoSQL style API that way. And then the third one, I know we're a little bit over time, but the third one I wanted to talk to you folks about is if your use case has any geo compliance or geo residency requirements. That is, you want your InfoSec to meet data residency requirements and ensure that Yugabyte database, although it's distributed, it stores data for a separate tenant in one specific geography. You can actually do that using Yugabyte geo-distributed workloads. And this is a classic example of your financial services or insurance companies using Yugabyte to go and do this correctly. So you can create partitions in Yugabyte for your Postgres tables. You can pinpoint them to a specific geography, and we ensure that data never leaves any other geography, even though it's a distributed database in that case. So I'll pause here quickly, Bart. Any questions on this slide?
Yeah, we got a few. So one of the things that I wanted to, you mentioned DBRE, and I think that's interesting because it's something that is seemed to be seen more and more. Mentioning how it comes out of Facebook, interesting because when we're talking about things like chaos engineering, we automatically talk about Netflix. We talk about Kubernetes. We're going to talk about Google because of Borg. But with the DBRE thing, starting to grow out a little bit more, seeing more folks self-identifying as DBREs. a thing that we talk a lot about in our community is making that transition from DBA to DRE, or sometimes from DBA to SRE. In your opinion, in terms of what an organization like Yugabyte is looking for, what are characteristics, qualities, experiences, technologies that you try to detect that make someone a good match for the necessities of that kind of a role?
I actually have a slide for that. I'm just going to paste it real time here, and I'll touch upon
good.
that. It's a
okay, cool.
great question, by the way, and something that we strive really hard to ensure that all of the Silicon Valley users as well as enterprises really go and take the DBRE model, right? So first of all, for the folks who are new to the DBRE model, it's a perfect book by Lane and Charity Majors. You can go and grab this. It's actually very cheap on O'Reilly or Amazon that way. But this basically talks about the inspiration that the folks got in Facebook by creating the SRE based on the SRE model in Google and bringing in DevOps culture to your DBA teams, right? So essentially what I talked about, infrastructure as a code, automation is a key. But when you're trying to go towards that kind of a thing, bringing that model or culture in your teams, these are some of the driving patterns from that book. Again, I've summarized the entire book. I'll send you the transcript for it as well. But these are the core 3 tenets that you should think about. That is, database responsibility is not a single DBA task. It's actually a shared responsibility across cross-functional teams. So developers, DevOps, key architects, all are the stakeholders in successful SLA that you have for your end users. Second thing is, you want to ensure that the patterns and knowledge that support each other teams and everything are very well documented and there are processes around it. And the DBRE book has amazing processes that you can just go and grab it without any modifications that way. The third thing that makes you really successful is having reference architectures and rolling that out easily without any hiccups, without any caveats that way. That is making sure all the stakeholders approve these reference architectures and click of a button using Jenkins or any other CI/CD pipelines, you're able to go deploy the fleet of applications that way. This is something that the DBRE really strives for and make sure that you can do it. So I've attached one Percona slide here from Lane Campbell, who presented at the Percona conference a couple of years ago on how exactly you can go embrace these DBRE skill sets in your org as well.
Very, very good. No, because like I said, it's just something, if SRE is new enough, these things sometimes is like, what language are we speaking here? Another thing with that too, like as we're seeing more and more companies, taking this whole idea seriously that yes, you can work with data on Kubernetes successfully, stateful workloads, et cetera. Do you think that the biggest issue about it is that it's the technology or that's the lack of trust and knowledge that people have?
Correct. It's actually, whenever you bring in a new technology in the org, there's always there's always pushback, I would say. It usually comes from lack of experience being number one, or having to do with one product or one technology really well, and the new technology is still up and coming. So it's not going to solve all the problems for you, right? So rule of thumbs that we go with most of our users is embrace what the new technology brings to the table, try to improve it with community support and everything, whatever you can, and see what benefits it gets you from cloud native aspects, as opposed to knowing your old technology really well, but not able to scale or meet your enterprise demands that way. So that's the most important thing, right? If you're getting disrupted by a Silicon Valley company in your core domain, it's time for you to rethink on the new set of technologies that they are embracing, and you should be much more ahead of them to go and embrace those technologies as well.
Very, very good. That's exactly the kind of message we're looking for. That's a good way to finish. We got a couple other questions. We can probably address those in Slack. This was a fantastic presentation. You really got a lot into a short period of time. We got all over the place. We got to look at a bunch of different things. Is there anything else you'd like to mention before we wrap up?
Correct. So I had one key homework for you folks to do it, because this is again on the backs of if you want to really use Yugabyte kind of databases in a core use case, then we have basically created this simple retail store example that can basically do shopping cart checkout and shopping cart, adding to the products and everything. And it's on back of all the CNCF projects. So you have Istio, Spark, Spring, React, and Yugabyte basically doing all of these things. Go try it out in the link that we'll provide you right after this conversation today. It's going to get you 100% scalable. That is, you can scale from 100 products to millions of products and scale out, scale down Yugabyte based on the transactional needs. And you get a perfect, the one thing that I was telling you about, perfect architecture to go about when you're trying to solve a system of record use case. So give it a shot right after this call. And if you have any issues, join Yugabyte Slack to make sure that all of your questions are addressed. again, we are one of the fastest growing distributed SQL companies on the planet. And we run a small club called Unicorn Club. That is, any customer who does more than 1 billion operations a day fits into this club. We have about 9 of them today, but only 4 of them have given us permission to use their logos. But it's one of those things where if you have a use case which belongs to the Unicorn Club in Yugabyte, please work with us. We'll ensure 100% on that one with you. So thank you, Bart and team.
No, that's great. It's really nice to see that, because in other talks, and that's actually something I take away from this, is that we talk a lot about every week about all these different technologies. Like, we got this session to do with you. Tomorrow we've got another session. We've got another session on Thursday, possibly even 2 sessions on Thursday. And a lot of it is that we get a lot of the technology stuff. We see a demo, but then it's like, okay, so then what's the next step? If I want to start putting this into practice, even at the most beginner level possible, what are my resources? You got a community, you got a GitHub repo, you can go and start applying this stuff directly. That's really, really nice. So that's something that I think we need to incorporate better as a community to make these technologies and experiences more readily accessible. Last thing we got to do, can you stop sharing your screen just for 1 second so I can share mine? So as a tradition in all of our meetups, we always have our secret artist who's behind the scenes. Let me see my screen. So while we've been talking, our dear friend Angel, who's an amazing artist, has been creating a visual summary, a graphic recording of the different topics that were touched upon. Obviously, we would need a much bigger space to cover absolutely everything, but it was a very, very nice summary. This was really, really good. And as I said at the beginning, it's a nice way to finish now. We're here to talk about why you can run stateful workloads on Kubernetes, why you should run stateful workloads on Kubernetes, because the what and the how are also important, but starting with that why, I think, is really, really good and gives more strength to the argument. Like you said, there's a lot of resistance to technologies at any point in time, but do you want to be ahead of the curve or get run over by everyone else that's adopting and catching on with these things? You're pretty easy to find on LinkedIn, Twitter. Folks want to check you out. We'll have links in the description. But thank you very much for your time today, Amey. I really enjoyed it and looking forward to having you and the folks back from Yugabyte soon. Shout out to Gavin for helping set this up. Shout out to our amazing interns for helping facilitate things in YouTube. And I think we're all going to be interested in hearing about the next steps.
Absolutely, Bart. I'm looking forward to meeting you in LA for the KubeCon stuff. So yes.
Yes, we'll be there. And remember, we got our CAP out. If you wanna put in something for KubeCon, we'd be happy to hear from you. And anyway, talk to you all soon, and see you in the meetups later this week. Take care, Amey. Thank you very much. Bye-bye.